All right, 7th grade, today you're going to do your practice test on page 545, and here's what I'm actually planning on doing. We're going to use this as your test grade for this chapter, because before the end of the year, I want to do a couple lessons out of chapter 10 that are going to be important for next year when you go into algebra, okay? So this will count as your test grade, but to help you with that, since we didn't have a review day, I'm going to do a problem that's exactly like every single problem that you're going to face on your practice test day. In fact, we're even going to do a couple of the actual problems out of there right in this video for you, okay? And so I want you to watch me solve one of each type of problem, pause your video, and then go do that same problem in your book while it's fresh in your mind how to do it, okay? And then start the video up again, watch me do a type of problem, pause it, go back to your work and do that same problem in your book while it's fresh in your mind. I know we learned a lot of stuff in this chapter, so some of the stuff might be a little rusty, but if you do your practice test that way, and we're going to call it your real test that way, it's going to go well today, okay? So, number one, here's one problem that's exactly like number one. They want you to write this expression using exponents, powers. So this one would simply just be -3 to the third power, right? You're going to do the same thing on number one on your practice test, or we'll call it your real test today, okay? Pause the video and do that right now on number one. Okay, on number 3, they want you to evaluate the expression. Evaluate's a fancy word for solve, right? And they tell you what these letters stand for. So remember to put them in parentheses, okay? And then you do actually have to do the math. Evaluate, right? 3 to the third power is 3 times 3 times 3. Careful, that's not 9. 3 times 3 is 9 times 3 is 27 plus 4, which gives us 31. Go ahead and pause the video and do number 3 right now. Okay, number 5 says they're going to talk about stars on a flag. I'm going to do a similar problem with desks in a classroom. It says there's 18 desks in a classroom that are arranged in a rectangular shape. Which of the following could be the rectangular arrangements? In other words, if we make it a rectangle, how many would you have going left and right, and how many up and down? If you have 18 desks, would 6 and 4 work? 6 and 4? No, that would give you 24 desks. That wouldn't work. 6 times 4 is 24. 3 and 12, would that work? No, that would give us 36, way too much. How about 6 and 3? If one row had 6 and one had 3, yeah, that would work, right? Because if you had 3 desks and 6 rows of that, 4, 5, 6, do you see how that's 18 desks? There you go. That would be an arrangement that would work. Now, for number 5, it'll talk about stars on a flag. What would be one of the arrangements that would work? In other words, just find the multiplication problem that equals the number of stars that they need to have on that flag, right? Okay, number 7, you're going to be factoring this monomial. Remember, a monomial is a chunk of whole numbers and variables with powers, right? And they want you to factor it. So the first thing you're going to do is you're going to grab your whole number, and you're going to make a factor tree. Remember this? Circle any number when you get to a prime number, right? And you can't go any lower. There we go. So, and then this one would be 2 times 2 times 2 times 3, right? All 4 of those numbers. And then you have to list off the letters for how many times they appear. B to the 4th, C to the 3rd, and D. Okay, if you want to write it like this, 2 to the 3rd power times 3 times B times B times B times B times C times C times C, that would be okay as well. Okay, either one would be acceptable for number 7. So pause your video and do number 7 right now. Okay, numbers 9 to 11, they're going to have you multiply or divide numbers with exponents, but they want you to write your answer leaving just the exponents. You don't have to fully solve. Remember, if you have 2 bases that are the same, 2 big numbers that are the same, and you're multiplying, you just add the powers together. Remember that? So this would become 8 to the 7th power, and you can leave it like that too. That's what they mean by express using exponents. Okay, in other words, you can leave your whole number and your exponent just like that. You don't have to actually do 8 to the 7th power, okay? Ooh, do you remember what to do when you're dividing? I put the wrong sign here. This should have been a division sign. What should you do if you're dividing 2 bases with powers that are the same? Okay, we need to subtract the powers. So this would become -6 to the 6th power, just like that. Don't forget your parentheses for the negative numbers. Okay, so if you're multiplying 2 bases with different powers, as long as the bases are the same, you add the powers. And when you're dividing 2 bases that are the same with powers, you subtract the powers. Remember those rules? Go ahead and do numbers 9 and 11 when those rules are fresh in your mind right now. All right, number 13 says, how many square centimeters is equivalent to 1 square millimeter? Write it as an expression with a positive exponent. Okay, so for this one, what fraction of a centimeter is a millimeter? In other words, how many millimeters are in every centimeter? If you look at your ruler on the centimeter side, that you'll find out that A millimeter is 1/10 of a centimeter. There are 10 millimeters. Now we're talking about square millimeters. What do you do when you square something? Don't you take it to the second power, right? So 1/10 times 1/10, right, would be 1 over 100. So how could we write this with a positive exponent? Okay, can you think of something times itself that equals 100? Well, 10 times itself twice, right, would be, and there you go. You've written it with a positive exponent, okay? That is the actual answer to number 13. Don't forget to show your work. Okay, number 15, they want you to write something using a positive exponent. Do you remember how to make you're never allowed to leave an exponent negative unless they ask you to, right? Remember how to make it positive? You put it over 1, and then you flip it. And when you flip an exponent, it always becomes positive. So do number 15 while that's fresh in your mind. Okay, number 17 is scientific notation. Remember this? This is the way to write really big or really small numbers in a special way that they use in science and math sometimes, right? Remember, if this exponent is negative, you're going to move the decimal that many places to the left. And if it's positive, you're going to move it that many places to the right. So here's where it is right now. Notice the negative exponents. We're going to go 8 places to the left. Here we go. 1, 2, 3, 4, 5, 6, 7, and then we'll fill in all these blank spots with zeros, and there we go. There's our final answer, 0.00000062. All right, so do number 17 while that's fresh in your mind. Okay, number 19 this is, very similar to. They want you to write a number like this in scientific notation. Remember, scientific notation, it's been a little while, we always want to have the decimal right after the first digit, right? So we want to move it right there. So how many times would we have to move it to get it right there? Here's where it is right now, right? 1, 2, 3, 4. So this would be 5.84, and you can get rid of the extra zeros, times 10 to the 4th. See how I did that? Okay, so when you move the decimal right here, don't get rid of these other numbers. Keep those. See, I kept those. The zeros, though, you can get rid of when you rewrite it this way. And we had to move it 1, 2, 3, 4 spots to get there. So there it is in scientific notation. Do number 19 while that's fresh in your mind. Okay, number 21, they're going to have you put a whole bunch of scientific notation numbers in order, but careful. Look what they do. They were tricky. They said greatest to least. You put the biggest one first. Often they have you do things in order from least to greatest, so be careful. They flip-flop that on you, okay? So remember, when you're first comparing numbers in scientific notation, look at the powers first. The bigger powers will be bigger numbers. So this is our biggest number. It's got the biggest power, okay? Okay, then do we have another one that's got a power that's bigger than all the others? Yeah, this one's going to be second biggest, right? Okay, and then if they have the same power, you got to compare the numbers. So this one here is bigger because it's a 5 times 10 to the second power, and this is the smallest, 2 times 10 to the second power, okay? So careful, from greatest, biggest to least for number 21. Watch out. Okay, for 23 to 25, you've got some power to a power problems. Remember, when you have a power to a power, you multiply the powers. So notice we have this 2 in here, so we got to do 2. So this would become 2 to the 6th power. And I don't believe on these ones, 23 and 25, just looking at what they do. Now, we can leave our answers like that. That's okay. You don't have to fully solve, okay? Let's do this next one. Notice this one has 3 things that we're all going to take to the second power because they're all inside the parentheses with that 2. So 4 to the second power, right? And then we have c squared to the second power. So we multiply the powers, c to the 4th. And d to the 3rd to the second power. So we multiply the powers, d to the 6th. And you could change that 4 squared to 16. That's fine. And there's our final answer. So do numbers 23 and 25 while that's fresh in your mind. Okay, then 27 to 29. They want you to decide if things are linear or nonlinear. Remember, things will be a linear line or linear graph if you can write them in this form. If you can write them with something y, right, equals something times x plus b, okay? Is this one in linear form? Can you write it like that? You cannot. Here's the key thing. You cannot because there's this squared here. Notice on the linear equation, nothing is squared. So if you have something squared, you'd say no. Now, don't just say it's not linear. That doesn't really explain. Say it cannot be written in y equals mx plus b form. Make sure you say that. Some of you on the assignment where we had to do this wrote, no, it's not linear. That doesn't really explain why, though. When they say explain, you have to really explain why. So you have to say, no, it cannot be written in y equals mx plus b form, okay? Is this one linear or nonlinear? I'll rewrite it right here. Can it be written in this y equals mx plus b form? It definitely can. I'll prove it. Watch. If I take away a 4x from both sides, I have 2y equals negative 4x plus 8. And then I could divide everything on both sides by 2. So I'd get y equals negative 2x plus 4. Hey, look. I wrote it in y equals something x plus something form. So you'd say yes. Now don't just say yes, it's linear. That doesn't explain. Yes, it can be written in y equals mx plus b form. Okay, that would be how you explain. Don't just say yes, it's linear, no, it's nonlinear. It doesn't really explain. And remember when you have a XY table like this, I'm just going to erase a little bit to make some room. It's linear if the numbers are going up by the same amount in the x's and going up or down by the same amount in the y's. Okay, is that happening? On this side, we just keep going up 1, don't we? Plus 1, plus 1, plus 1. So that side's good. Is this side good? Negative 1 to 3 would be plus 4. 3 to 7 is plus 4. And 7 to 11 is plus 4. So yes. Now, don't just say, yes, it's linear. That doesn't really explain yes. The numbers go up consistently would be a good way to say it. In other words, they go up by the same amount, okay? So be careful when you're explaining today. Don't just say, yes, it's linear. No, it's not linear. That doesn't truly explain why. Either, yes, it can be written in y equals mx plus b form, or no, it cannot be written in y equals mx plus b form. And for these table ones, either say, yes, they go up consistently, or no, they don't go up consistently, okay? That'll be how you explain those. Do those problems while that's fresh in your mind. Okay, 31, you're going to graph. Do you know what your graph is going to look like just by looking at the equation? Hopefully you're starting to pick this up, but notice it's something squared, right? We had graphs that looked like this that had nothing squared. Those just gave us straight lines, right? And then we had graphs with something squared in them. Those are our parabola graphs. So it's going to make a V or an upside down V, right? Okay, we had something to the third power. That was on Monday. And those gave us those funky graphs that kind of make an S curve, right? Okay, and then we had our exponential graphs where the variable was the x that went straight up in a J shape, right? So this is one that's going to make a parabola, a V shape, because it has something squared, right? It's a quadratic equation. And so, remember for these, and for number 31, which is very much like this, since we need our V shape, we need to have negative 2, negative 1, 0, 1, and 2. We have to have those numbers so we get both sides of our V, okay? And remember, the best way to solve these is to put a big blank where the x is going to go and fill in those numbers as you go. So let's do that. If I put a negative 2 in there, negative 2 squared is 4, times 3 is 12, minus 2 is 10, right? If I erase that and I put a negative 1 in there, what happens? Negative 1 squared is positive 1, times 3 is 3, minus 2 is 1, right? If I put a 0 in there, 0 squared is 0, times 3 is still 0, minus 2 is negative 2, right? If I erase that and I put a positive 2 in there, or positive 1 we'll do first. 1 squared is 1, times 3 is 3, minus 2 is 1, right? And if I put a positive 2 in there, 2 squared is 4, times 3 is 12, minus 2 is 10. And then when you graph this thing, negative 2, 10 would be way up here. Negative 1, 1. Notice our V shape that we're getting. 0, negative 2, 1, 1, and 2, 10. Notice our V shape. Remember to curve the bottom of your parabola, your V shape. And there you go. Do number 31 while that's fresh in your mind. That'll be a quadratic equation. I know that because there's a squared going on here, right? Look at number 33. Can you tell what the graph's going to look like even before we do it? Remember, if it's something squared, we'd get a parabola. If it's something to the third power, we get our funky S-shaped thing, right? And if it's the power itself that's missing, we get a graph that looks like this. Remember that? Yeah, we've learned all those different graphs this chapter. This one is the power is missing. Remember, when the power is missing, you don't have to do any negative numbers. Awesome. You can just go 0, 1, 2, 3, and that'll give you more than enough information because this is going to make a graph that goes up like this, right? So I'm going to fill in these x's right above the 3. So let's put in our first one in blue right here. Remember, anything to the 0 power, really, really important. Anything to the 0 power, whether it's 1,000,000 to the 0 power, 100 to the 0 power, or 3 to the 0 power, always equals 1. So this equals 1 take away 2. So 1 take away 2. In other words, 1 plus negative 2, right? We subtract them and use the sign of the bigger number. Negative 1. Okay, so let's erase that. Let's put a 1 here this time. 3 to the first power is just 3. Take away 2 is 1, right? Next time, let's put a 2 in there. 3 times 3 is 9, minus 2 is 7. Let's put a 3 in there. 3 to the third power is 27. Take away 2 is 25. So you might want to use this type of 1 centimeter graph paper for these type of problems, right? Because they go up really fast. And so what if we count by, like, how about 2s? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right. And then on the bottom, you can always just count by 1s. That's fine. Okay. Notice what's going to happen with our graph. 0, negative 1. So I actually will have to extend my graph down a little bit. Here's 0, and then negative 2 would be down here if we're counting by 2. So 0, negative 1. Our first dot would be about right there, right? A little bit below our graph. 1, 1. Okay. So 1, 1, right? Halfway between 1 and 2. 2, 7. And then 3, 25. So that's a little bit above our graph here. But notice what we're getting. We're getting this J-shaped graph because it's an exponential function. So for number 33, you'll get a J-shaped graph as well. Okay, hopefully that gets you going on your test today. We'll call it that. It's going to be your final test today. Use this video and pause each time, or rewind and go backwards if you need to get some help. I can still help if you're really, really stuck after that, okay? But since we're treating this as a test, I'm not going to check maths today, but I certainly will talk you through any that you're stuck on. Don't be afraid to reach out for help, and I'll at least get you started on the problems or do a little bit of it with you so you get on the right track, okay? And then we'll be ready to move on to Chapter 10 then tomorrow. Hopefully that helps a lot to have this video. Reach out to me if you need any help, guys. Have a good day.